on the meaning of place, and in doing so recognize the various traditional lands on which we do our business today. So Deakin University would like to acknowledge the traditional custodian on lands on which our university campuses are based, the Wurundjeri people of the Kulin Nation on whose country our Geelong campuses are located, the Wurundjeri people of the Kulin Nations on whose country our Burwood campus is located, and the Pickwurrong people of the Maar Nation on whose country our Warrnambool campus is located. I am myself located in Wurundjeri country, and on behalf of us all, I pay our respect to all Aboriginal and Torres Strait Islanders traditional custodians, elders and ancestors of all the lands from which you might be joining our gathering today. I express our gratitude to their care of country, which continues to sustain us as it has done so for millennia. Education has a long and rich heritage on this continent, which we aim to honor and reflect in the ways we teach and learn and do research. So welcome to the seminar. I'm Thuong Hoang, together with Toyja Singh. We are data culture theme leaders of the Deakin Science Society Network. So our thanks to our partners at the Critical Digital Infrastructure and Interfaces Group and the Centre for Regenerating Future and SSN for hosting this seminar. Just a brief running order. So Dr. Amit Kumar will have a 45-minute presentations and with our responses from our discussions, and Amit respond for about 20 minutes, and we'll wrap up an open discussion in the final 15 minutes or so. For those on YouTube streaming, so I think we will have a different channel for you to engage with us, as well as our Zoom chat over here. So our discussion for today are Dr. Luke Heemsbergen and Associate Professor Peter White, and thanks to Karina Traits from SSN for organizing the sessions. So today we have the honor of having Dr. Amit Kumar presenting his topic titled Beyond the Classroom, How Augmented Reality is Revolutionizing STEM Education. Dr. Amit Kumar is a passionate educator and a researcher with over 13 years of teaching experience. He holds a PhD in engineering and technology, specializing in augmented reality for engineering education. Dr. Kumar completed his bachelor degree from Chitkara University in 2009 and his master's degree from Chitkara University in 2015. His expertise spans rapid prototyping, Internet of Things or IoT, embedded systems, augmented reality, virtual reality, AR, VR, image processing, web development, machine learning, and robotics. Dr. Kumar has published over 29 research papers in international journals and conferences and has conducted more than 30 workshops and expert sessions on cutting-edge technologies. Recognized for his contribution, he was awarded the AWS Cloud Ambassador by Amazon in 2019 and honored as a mentor for promoting industry academia partnerships in 2020. He's also received the Young Emerging Leader Award at Chitkara University in 2019 with 2 design patents granted and 9 filed. Dr. Kumar is currently heading the Electronic Design Center at Chitkara University, driving innovations and research in engineering educations. So please join me in welcome Dr. Amit Kumar.
Thank you, Thuong. It was wonderful. And let me share my screen. Okay.
Thank you. Over to you.
Thank you, Tom, for this introduction. And thank you, SSN, for organizing this seminar. So that is a brief about me. Already Thuong talked about me. So I'm working as an assistant professor in Electronics and Communication Engineering Department since 2015 at Chitkara University. And I visited Deakin University as a visiting research fellow under SSN in 2024. Currently, I'm heading IoT and Embedded System Vertical at EC Department of Chitkara University. And simultaneously, I'm taking care of Electronica Design Center, which is the Rapid Prototyping Center at Chitkara University. Till date, I have published more than 30 research papers in different journals and conferences, and now there are 5 patents which are being granted and 15 are published. So I already completed 2 research projects, and 1 research project is going on that is in the same area for promoting the STEM education. And my expertise are into the IoT, embedded systems, AR, VR, engineering education, AI, and machine learning. So before we jump into the topic, for the STEM education, for which we are here to understand how this AI technology has revolutionized the STEM. Let us understand the background, what is a STEM education and what is the need to focus onto the STEM education. So as you can see with the acronym of a STEM, it stands for science, technology, engineering, and mathematics. And if you see onto this picture, which is gives the whole impression why this STEM is. So here S means if you're talking about a science, it says about observing, experimenting, making predictions, and asking questions. That is what the science people do. Then when onto the technology side, for which we are correlated for both technology and engineering, because we are continuously in the phase of innovation, involvement, using new tools, designing new tools for teaching, maybe for engineering and other. And then as all of us being engineers, we primarily focusing upon solving the real-time problems, this community problem most of the time, which we try to solve through engineering. And in order to do all this, we need a maths to understand the pattern, to analyze the things that will help us to evolve the solution in a more and much better way. So what is the need for STEM education? According to the labor statistics graph, it is the data that is published by US government. They have figured out that by 2021 to 2031, means in next 10 years, the people working in this STEM, their job is going to be increased by 10.8% as comparison to the people who are working in non-STEM domains. So it shows that the STEM domains the people working in the STEM domains has higher rate of employment in the market. There's another data which shows overall, it is according to 2020. Again, it is presented by OECD, which shows the percentage of total graduates in STEM fields. If we talk about this, then we see that China is top in this list. China is currently generating 3.57 million of STEM graduates, which contributes 41% of their total graduates. And if we see India, which is onto the fifth, it is producing 2.25 million of STEM graduates, which comprises of 30% of total graduates in a particular year. So this data is published in 2020, and we can see from 20 to 25 this year, this might have increased to around 30 to 33%. So how all this STEM education evolved in India? So as we see, in the year 2000, there was an IT boom in India with the establishment of the companies like Infosys, Wipro, TCS, Mahindra. They all come up into the market to develop the IT industry in the India. And then which brings in next 10 years, a global shift to the market. Now, India is being recognized as one of the major players in the IT industries. And seeing all this shift from a local player to a global player, Government of India has taken some initiatives. And from 2016 to 2020, they have come up with the AIM. The AIM stands for Atal Incubation Mission, where the government is targeting for finding new innovations, new student mind to come up with their ideas. And that led to a startup wave in India. And we have launched our revised after the independence, that is 46 years, that is National Education Policy 2020, which focuses on STEM education in India. So this policy was launched in 2020 in India, whose main agenda was to create this STEM workforce for the future. Seeing the generation, seeing the pattern of upcoming jobs scenarios into the market, government come up with this policy. And in 2025, we have a lot of startups, and the STEM training centers are established at school level and then at the university levels. Now, there is another statistics which talks about what is the current STEM education status in Australia. So as we see in this graph, this was published in 2019 by Alan Finkel. In one of his talk, he presented this data where he says 32% of these university qualified are the STEM, whereas 68% are from VET, that is Vocational Education Training Centers in Australia. Out of this, 29 means 16% of STEM qualified people are females, right? So as you can see, the growth of from 2006 to 2011. So in STEM, you can see there is a 15% growth as compared to 26% in non-STEM. Seeing all this trend in Australia as well, so there was a establishment of a national STEM school education strategy of focusing for a 10-year school to the higher education level. And they have launched a national STEM school education research toolkit, which is responsible to provide all the resources that will be helpful or needfully required by the schools to establish this STEM education center at the grassroots levels. And Ellen also talked about that STEM education will be addressing the real-time problems and is useful to us as the wider community and in many, many ways. Now, when we see about the STEM education, the three focus area comes up. First, the future demand job. Second one is economic growth. And third one is solving global challenges. So we can see 70% of future jobs, according to WF, that will be in the STEM domain area. That is why we need to promote STEM education at school level, and we need to train students for the future jobs. Once they are ready, and they can be directly involved in the economic growth of any country, because the STEM fields are going to drive the innovation and global competitiveness into the market. On to the other side, the STEM will be helpful in solving global challenges. It may be to clinical side, maybe to the healthcare side, and sustainability and other areas which will be requiring a later solution. Now, what are the benefits of STEM education when we look onto this? The first is for critical thinking and problem solving. Because once it was in 1927 when it was initialized first in US, when they conceptualized this STEM education concept, they find it out when we give a problem to a student, it builds up critical thinking and problem solving skills into them, which leads for the creativity and innovations, and which again fosters collaboration and teamwork, which overall makes them to ready for their career and to get employed as early than the non-STEM domain people. So there is a short comparison between the traditional education system versus the STEM education system. So as onto the left-hand side, you can see it's all about hands-on experiment where we talk about project-based learning, inquiry-based learning. Onto the other side, which in a traditional education system, we have lecture-based systems, and it follows a fixed set of the curriculum. But when we talk about a STEM, you can experiment a bit with your curriculum. You can change, which encourage student to learn beyond the curriculum and to come up with their idea. That is where we can see the innovations coming. They will be solving the real world applications rather than focusing only upon theoretical learning, which was happening around 20 to 30 years back. Also, when we talk about STEM education, they foster collaborative learning, whereas in traditional education system, it was individualized. It's individualized focused. But still, we talk a lot about STEM education at different grassroots levels. There is a need to solve, because these are the challenges which we see in the current era. The first one is infrastructure and the resources. Second one is teacher training and the capacity building. Third one is curriculum and remote learning culture. Next is gender and socioeconomic disparities. Industry academia mismatch is there, funding and policy execution. So all these are the challenges which are posing hindrance to flourish STEM education at their best level in different geographical spaces. If you see about two different regions which we are talking today about, India and Australia, both countries are taking the STEM education as per their geographical constraints, and these all are the common challenges which I could find it out which are hindering us. So we are being the teachers and the researchers, we are more focusing upon the first three parts: how we can create, how we can train the school teachers, how we can enhance the capacity of the school teachers to understand the concept in a better way, how we can build up a low-cost infrastructure which can be commercialized or which is a scalable, and through using all these things, how we can change our curriculum that will remove the rote learning culture in the present education scenarios. So once we would be able to solve first, second, and third challenge, then we can look upon to the gender and socio-economic disparities which exist. As we can see in the trends, there is always disparity between a gender. When we talk about the technical education system, you see the sometimes in some of the trades, the males are dominating. In some trades, the females are dominating. But with the advent or the boom of IT or internet services, you can see now the female participation in computer programming or computer oriented courses are more than the male. Once again, we will be able to solve this industry academia mismatch when we have a fixed setup for this. And this all needs the funding and policy execution support at both government level, which is at the state level and at the national level. Then only all these challenges can be met. Focusing upon current what we can give the solution, what solution we can post up, or being the technologist areas or working into the engineering and research, which we are working in last 1 decade. This could be the solution. The evolution and potential of immersive technologies for unlocking transformational experiences in this domain. Now, before we proceed to the next section to understand the immersive technologies, so it's a very simple definition that is given about immersive technologies. Immersive technologies, it creates a distinct experience by merging the physical world and the digital world, which may be simulated into a reality. So they are a merger, these environment, a merger of two different worlds, a real world and a digital world. So once you are talking about immersive technology, then you should talk about what is an immersive experience, because using immersive technology, you are going to feel this immersive experience, an experience which pulls a person into a new era, which pulls a person into an augmented area, which enhance everyday life with the technology, where you are experiencing a whole new world where you get immersed. You feel you are out of this world and you get drawn into a new third world, which is called as a digital world nowadays. So it's one of the well-framed continuum given by Azuma in 1977 that is called as reality virtuality continuum. On to the left-hand side, you can see there is a real environment, and as you move from left to right side, you are going more towards the virtual environment. So it starts with the technology intervention called as augmented reality, which says that a digital content from a virtual world or a digital world is overlaid onto the top of the real environment. It means you are not losing the real environment effect, but you can experience the digital environment effect in the real sense. And when we move on to the center, there is another technology that is called as mixed reality, where both virtual and real environment interact side by side, and you are not losing the real environment effect. But when we talk about onto the extreme, which is present as virtual environment, it talks all about the cutoff from the real world, and you are completely immersed in a 3D world. You are out of this real environment and you would be only immersed into the virtual environment where you can see you're shut out the real world. So this is one of the examples when the AR is being developed. So it says that AR is the bridge between real world and the virtual world. So you can see this is a mobile phone camera which enhanced human perception. So once you are using your camera as an input device, you can see all this information onto your screen without navigating any other things. So this way, you are augmenting the digital data onto the real data, and you are into the real environment and immersed with the digital data. So it all starts with Azuma, who's presented in his research in 1997, the standard definition for AR, which says this AR combines real and virtual worlds, but both can be seen at the same time, means you are not losing the effect of real environment, and On to the next side, it will be an interactive in real time. So both virtual content would be interacted to the real sense. And registered in 3D environment means in the real environment, you'd be able to see all the virtual or digital objects. Now the question arises, how does this AR is revolutionizing the STEM education, which is our focus to understand. If we talk about how does AR has impacted in education, we need to first understand about quality metric rubrics, which says in a classroom, in a typical classroom, the interaction is of three types. The interaction between student and a teacher, interaction between student and student, which we call as a peer interaction, and interaction between student and the content. Based upon all these three interactions, we come up upon understanding how does the learning happens. In order to learn, an environment is required. The environment can be given by a classroom, a laboratory environment, a library, or any other place. Now, these environments can be technology enabled, cannot or may not be technology enabled. But as we proceed with the technology, we again see the advent of ICT-based classrooms. We see the emergence of smart classrooms. And the next is the immersive technology-based classrooms, where we talk about AR, VR, and MR-based environments. So all these environments are helping you to enhance your learning experience of the concept. So this is a comparative analysis of two different setups of classrooms. So onto the left side, you can see in scenario one, which is a typical traditional classroom scenario where a teacher would be presenting the content using this presentation mode. And onto the other side, you are having a classroom scenario where you're representing through AR technology. So you're teaching the same concept, but in the scenario two, you can see it has more engaging effect than the scenario one, which attracts students more towards the concept and it increases their inquisitiveness to learn the concept well. And as we say that by visualization, it impacts our brain to restore the content for a longer duration than just reading the content. So visual effect has more impact on human brain memory than the reading effect. So now all these questions come up when we start to research in AR using for education domain. So does this AR experience is accomplishing the pedagogical goals or objectives of the learning? What do you want to do? How does this AR is retaining the concept, helps in retaining the concepts for longer duration? How does AR experience impact students' learning, motivation, and knowledge gain? Does the use of AR instructional material is going to lead the lower the cognitive load, or is it going to increase the cognitive load of the learner? Does an AR-based learning system play a significant role in developing a critical thinking skills, laboratory skills, and spatial skills, which we talk about? It is the base if we focus upon STEM education, because STEM education talks about building skills like critical thinking skills, laboratory skills, problem solving skills. So the genuine question is, does this AR technology is going to help in building these skills significantly impacted or not? So while implementing the AR in the classroom scenarios, it gives you the facility to access the data from anywhere. So your data or your learning material is now accessible. You are not restricted only to a classroom environment. So no special equipment is required. Generally, camera-based systems is required. So no, you can say costly equipments are required to have an experience of AR. Then higher student engagement and interest is seen when we implement AR in the classrooms. It improved collaboration capabilities between the students. A faster and a more effective learning process is given by augmented reality technology in AR. Now, when we develop about these are the things when we need to focus when we are developing any system that is using AR technology. The first thing is about there is a continuous integration of hardware and a software. Then it goes for tracking and registration of the system. and then interaction and a display. So all these blocks are required where we talk about there is a hardware, there would be a software, then tracking mechanism would be there, registration mechanism is there, interaction between the real and the digital world, and display. So how you're going to display the digital world to in the real scenario. So all these factors would come into play when we are developing any AR-based systems. So this is one of the typically AR-based system which I worked, and it's, you can see, so there will be a market-based, because when we talk about AR technology, so in order to get the real content, so we have two topologies. The one is marker and another is a markerless. So the markers are easy to be used and scanned, whereas the markerless has its own complexities, which can be solved with the more complex programming structures. So here I worked upon to the market-based mechanism topology to develop the complete AR system. You can see there will be one display device, one camera will be there to get the input, which will be scanning the AR marker. Once this marker is scanned properly, it is registered to the backend, and then the backend will be popping up the digital data which is already stored into the application. Now that data will be published onto this display device. So this is a whole system flow while working with the AR-based learning systems. So these systems work upon the framework of CLT, means as per the curriculum, it focuses upon to meet the learning outcomes, and the learning activities are defined to achieve those learning outcomes of the course. And from the learner's perspective, it is focused that a cognitive load of a learner should be reduced, and it improves their learning gain and the motivation. And onto the technical side, we are developing an AR application, which might be a tabletop AR application, web AR application, or it can be a mobile AR application. So this is one of the demo which we worked upon the web AR application. So I just play this one. So the software which we have used here is the Unity, which is the traditional game-based engine, you can see. So in this, you can see these all tasks onto the top of the corner. This is the task which we wanted a student to perform while interacting with the real world. So once the marker will be scanned, so you can see. So this is a 3D generated data which talks about an Arduino Uno board, which is the most popular board that is used for the STEM education. And onto the other side, you see one of the motion sensors. So this is the 3D data which is generated when we scan an AR marker. And onto the left hand side, you can see a software program is there. So the first thing is the integration of a hardware and software is already shown here. And onto the left corner of, you can see the task. So these all are the tasks a student need to perform while he wanted to interact this motion sensor with the Arduino Uno board. So first task is he need to connect the wire for the data, he need to connect the power, and then to test the components. So let me play further. So you can see as the user, this application gives you drag and drop. So you just need to click onto the board and then onto the sensor, then it will be automatically connected. And then once it is connected, it will give the message to you. Into the bottom, you can see the pin connections are done. And simultaneously onto the left-hand side, you can see all these checkboxes are ticked. Now the last checkbox is left, which is called as to test the components. So if you see in the next, again, you are going to connect. So then next we tried to test for the component. So once you test, it gives you the error message. If you have made the connection, when correct connection, then it will be showing you no error. So, but in this case, you made one error and the time spent is 0.11 seconds. So this all statistics will be used by a teacher to understand the learning curve of a particular student in the class. And based upon this statistics, a teacher can change his strategy to teach or to introduce new concepts or to give him the more resources to learn or again retry these concepts. The benefit of using this AR is it takes out the fear from a student's mind to burn out the practical or real hardware, because when the students, when they are in the age group of 9, 10, 11, and 12, they are more afraid of burning these real boards. They cannot buy it. And again, if we see the first challenge of STEM education, that the infrastructure is limited. You cannot burn out boards every day, and you cannot buy new boards. So developing this type of applications helps a student and a teacher both to understand the real concept in a virtual environment without the fear of losing the board or the procurement of the no boards. So this all application can give you the complete summary of your learning, what you have learned, what was right, what went wrong, and how you can improve as well. So in the next third experiment of this, where soil moisture, you can see how this soil moisture sensor generates the values, and all these error messages, they all will be recorded so that you will be able to identify the correct circuit connections. So these all are the interaction which is offered by AR. Means you can drag this component, you can zoom in out, you can zoom out, you can see more clearly about what is this. And whenever you click on any of this component, you can highlight and you can learn more about this component. So you need not to switch from one learning environment to other learning environment to learn about a particular IC or a particular pin of this complete board. So you once you click onto any area onto this board, this AR application will tell you about the function of that particular pin, the function of that particular component in this board, and how you can use it. So that is a way this AR technology is revolutionizing the STEM education, where a student in a same environment would be enhancing his learning experience by interacting with a 3D or a digital data and learn more about this. So this is then about a motion sensor, and that's it. So this is a short demo of the web AR application which we developed during this visiting fellowship. And the main focus is how to enhance student learning experience while they work upon to the real hardware. So as we are again bound by the technology, used to use the technology, and when we use the technology, again there are some of the challenges. When we use the AR also for the education, again the infrastructure setup is required. Means the camera-based system, although the cost is low, but a small change in the infrastructure is required. Then alignment with the curriculum, which is very much required, because most of the research is happening to use AR for entertainment, for defense, for medical services, and all that. But their alignment to the STEM education, this area has been very niche. So this area has a lot of potential, and a lot of application has to be developed so that they can be aligned to our curriculum. So we should not be changing the curriculum, but we should be developing a technology which is aligned to the current curriculum and help us to create the STEM workforce for the future jobs. Then the third would be again experience staff. That for this continuous training, teacher training programs, online and offline, because now we have the internet facilities. So online training programs are also available, which is going on to train the staff at school level and the at higher education level. But the last point is about high development cost, because developing an AR application, it is a cost. It consumes a lot of cost initially in the development, but once you develop, you can scale it a mass, which is very quick for the scalability. So these all are the challenges which in near future which will be solved, and we can see more and more applications which would be using AR for the education. So these all are the some of the research outcomes from my area which I worked. So some of them, the journal publications you can see over here. So now I would like to take a moment to acknowledge Dr. Shivani Malhotra, Dean, EC Department, Chitkara University, India, for encouraging me to apply for this fellowship. Dr. Imali Dia, Senior Lecturer, School of IT, Deakin University, for hosting me for this fellowship, and Karina from SSN team for coordinating and all this. And thanks to Chitkara University for giving me this opportunity to explore my potential at Deakin University to understand and go through this visiting fellowship. And thanks to Deakin University, Australia, so where I spent my 3 months during and doing this research work. Thank you.
Thank you, Amit, for your presentation. I love the demos at the end. It's actually really good to see how technologies are being sort of implemented and developed as well. So, and then you see our participants are joining in to thank you for your presentations. So for next step, I would like to invite our discussants for today's sessions. Dr. Luke Heemsbergen, whose research and teaching light a fire in build bridges between digital communications and everyday life. He makes new technological relations and power structure visible and knowable. His research approach incorporates community and science and technology studies to engage our social study and diverse technology subjects such as WikiLeaks, 3D printing, augmented reality, and antagonistic algorithm with diverse national and international partners. And our second discussant, Associate Peta White, who is an Associate Professor in Science and Environment Education at Deakin University. Peter co-directs the Center for Regenerating Future. The center supports transdisciplinary collaboration between researchers who are committed to addressing Anthropocene challenges, decolonizing knowledges, and taking a transformable approach to ecological justice. So I would like to invite Luke, our first discussions, to ask for response.
Sure. Thank you very much. And Amit, that was wonderful. Thank you so much for that really detailed look at what you've created. And I think it's so wonderful to see these ideas put into practice so we can start understanding how they work, but how they don't work, how, what needs to be done and what it touches on as you've highlighted in some of the interactions that you've encountered and are visible, I guess, through the published research that you put up on the end there. So that's just lovely. I think I wanted to start by thinking, I really love that to hear that the fear to failure was taken away for some of the students, right? Whether it's breaking the tech or like cooking their Arduino or otherwise. I think that's a wonderful thing. And it's wonderful, obviously, from like a material perspective, but it's also wonderful for those, I guess I'll say, affordances of education that AR might allow when you're talking about the hands-on project-based experimentation, where you're not scared to then follow a certain process, right? A certain curriculum that has what I'll say is physical world effects. So that's really lovely. And it not only lovely, I think it speaks to some of the power that augmented reality or digital simulation can have, right? And that's really focusing on the things that the physical world can't do, and thinking about from like a pedagogical perspective, how can when we're creating relations or interactions that the physical world would otherwise not be able to do, maybe that's where we can push the pedagogy. Maybe that's where we can see when there's new types of learning, new types of experiments that we can involve our students with that like physically wouldn't be possible otherwise. So I really like that point, and thought that's somewhere I can see these ideas of AR and mixed reality coming to the fore, virtual reality obviously as well, but yeah, I think that's quite interesting. And I think, I mean, I had a question for you, and I realized this, maybe I won't go over time here, but one of my questions for you was sorry, I'm just looking at Yeah, I mean, so I think you started talking about the infrastructure and teaching the teacher and, being able to remove rote learning, these kind of, okay, I'll say like procedural changes, right? And infrastructural changes you hope to, and just correct me if I'm wrong, but you hoped would come first so that we could, in STEM education, so that we could start thinking about how to reverse or change or acknowledge some of the gender issues, reverse or change or acknowledge some of the socioeconomic issues that come from this kind of education. And I was interested to just hear more of the logic there, if I understood that correctly, because the experiences I've seen other faculties or universities or nations, I'll say, other than India on that respect, actually goes the other way, right? Whether we call it affirmative action or something else, the idea is, can we diversify the teachers as the first step, and then see what happens to the curriculum, and then see what happens to the infrastructures that are built, from the sense that a lot of the tech and a lot of the infrastructure and a lot of the pathways that enables were not designed or thought through from that diverse perspective, and then it becomes harder to use those infrastructures and technologies to allow different types of thinking. So I just wanted to hear maybe a little bit of clarification on that logic, or if I've misunderstood. And I think, I mean, other than that, it got me thinking about what we think of as traditional education and what we think of as STEM enabled education, and the space of tools like AR in there. And I'm thinking, how do you enable, or how do you ensure designs that are AR based or mediated through AR or VR, mixed reality, don't flow into the lecture based things, don't flow into a very fixed curriculum, when you can't in fact tinker your set and your path that's been programmed in, right? When you are focused on virtual reality, especially, a very individualized learning experience. I guess that the second question I just want to hear more of is, like, that is, to me, a really pertinent design question, and I'd love to hear from the work you've done, how you kept it towards that collaborative, and I mean, I think we saw some of the real world, but yeah, encouraging experimentation, that collaborative piece, when the medium of AR, or again virtual reality, could very much go a different way, whether it's immersive or not. It still might be lecture based, following a curriculum, the rest. So yeah, thank you very much.
Okay. So look, I'll tell you. So it all started in 2016, because it's been more than a decade I'm teaching this embedded systems. So I am teaching to the school kids as well. So those who are in the age group of 9, 10, 11, 12, to some of the schools nearby my region. So I have a lot of interaction with the school kids, and then to our university kids. So there is a huge shift talking to a student who's the age group of 9 to 15, and then you're talking to an age group of 18 to 21. But the one thing is similar in both of them. That is, whenever they wanted to try something, they have a limited resource. And we need to create easily scalable infrastructure resources for them so that they can use it. Because the first fear comes to your mind because they have the labs, and the labs, the resources are limited. If one thing burnt out, then it takes a whole lot of time to procure the new items. So this AR technology helps to create a small scale infrastructure. I can show you one which I initially worked upon. So this is one of the board, simple board. So this is the AR marker. This is a real hardware embedded onto this, and these are the real LEDs, which student can use into the digital environment. They program it and upload onto the real environment. So until unless you click onto the upload button, you are not playing with this real, you are only superimposing upon AR environment. So once you are happy with the AR environment, you click on upload button, then this real environment, will be come into action, and then these real LEDs will be switched on. So that is why I try to design a system where both real world and the virtual world will be overlaying, and we are using this phenomena to take out the fear from their mind. So once you are ready, yes, I know. Then from a teacher perspective, the few things are required. How can I assess whether my student has learned or not? How can I assess what is the learning curve of a student while he was doing one particular experiment? So I need to focus upon all those things. So I go with the second idea where I just added up the faults. Can I measure the fault? How many times there is a wrong connection? How much total time a student is taking? Because if there is a one very simple experiment, it should be ideally finished in 1 minute. But a one student has taken more than 1 minute every time. So is something, do this student need a personal attention of a teacher? And when we talk about the VR, in VR, you are out of this world. You are not collaborating with your peers. But when in a classroom setup environment, you are using the AR, so you can have the peer interaction. You can ask your peer how to do this. I'm not getting it. And at the same time, if you have a big screen, so multiple people can interact with the digital content. And this digital environment is giving you the facility to be in the same environment and explore more. Otherwise, if I need to learn about this development board, this Arduino board, I need to look for the data sheet. I need to look for circuit diagram. I need to look for the power supply requirement. So now in this same application, I can give all the information which is required for a student to get started. So that because when a student shift from a one learning environment to another, he has to switch from one tab to second tab to third tab, his concentration hinders. When he gets all the information at one place, that increase the concentration of a student.
Thanks. Peta, do you want to comment as well?
Yeah, thanks very much. Thanks, Luke. And Amit, thank you so much for your presentation. I'd like to acknowledge I'm on Wurundjeri country today, and just a shout out to the greater Anthropocene challenges that I think we're all facing. And I really appreciate listening to your presentation today with those challenges in mind, because I think, you know, you're addressing that right at the cutting edge. I'm an educator. I've spent a lot of time in classrooms thinking about how to encourage young people to be interested, engaged, and to learn science. And I think all of those things are really different. So what I liked hearing in your presentation was the idea that you're really focusing in on student engagement. I mean, yes, you're attending to learning resources, paying attention to accessibility, gender considerations through accessibility. But the idea of creating a learning experience that is immersive, that is like modeling. So we use modeling a lot in science education. So you are working with the ideas of representing, but in a very tangible way and in a manipulatable way. So often our models are not as manipulatable as we might like them to be. We use simulations a lot in science education. And so I see what you're suggesting in AR as being really very similar to that. And I think that's really great. I was really curious about your thoughts about decrease in the cognitive load, because in lots of ways I could see that it actually might increase, in that, you know, you're creating an exciting, stimulating opportunity that requires physical doing. I think in education we're really familiar with the fact that doing enables learning. But then I think hard about divorcing my thoughts around engagement with those of learning. So in the research we do, we pay a lot of attention to working with teachers and students to find out about their experience. So I'd really like to ask you some questions about that. I love that you talked about the removing the fear. I thought that was really, really important, especially when we're talking about the equipment that you're talking about. And again, scalable resources and accessibility, just so important. The teaching support, I think, is really interesting. Often in the area that I work in, climate change education, I find that teachers are quite nervous about entering into newer areas or current contemporary thinking. And so paying attention to how you support teachers I think is I'm really pleased that you've been paying attention to that. I was curious about your comments around the curriculum, however, because I think the curriculum needs to change. And I think, you know, working out the process for that political action and moving systems and ideas into place to enable that kind of curriculum change is really important. I think our work in education so often needs to connect to policy, and often we don't do that piece of the work because it's really hard, and we're paying so much attention to what we're doing with our young people, which is actually where the fun is, I think. So I can totally connect with that. In Victoria, we have tech schools. I'm really hoping that you explored tech schools while you were here, and appreciate that that was the Victorian government's strategy for engaging in high quality contemporary technology with our students in particular schools. The Victorian government has just implemented another 10 tech schools across Victoria. So it's a really exciting model. And at those tech schools, they spend a lot of time figuring out what is the high-end, cutting-edge technology and how will they implement that with young people. So if you come back to Australia, let's make sure that we get you into talking to some tech schools, because I know they use VR and I know they use AR in some ways too. But I wanted to share a little experience about that I've had recently working with Toya Sinke about AR. And I think it's given me real insight to what you're saying today. So I just wanted to share how incredible it is to watch young people's excitement when something as fantastic as a local frog species actually pops up and becomes the mediated learning facilitator for them. And again, thinking about the engagement of it all as being really important, but then paying attention to what are the young people learning. So I felt in your context it was manipulatable skills. You mentioned really clearly that the AR is a collaborative experience, not just like VR and out-of-world experience. I think that's a really important thing, a good sales pitch in education, that you're teaching creativity skills, you're teaching collaborative practices and creative thinking. Yeah, I think I'll stop there. I've got lots of questions that I'd love to ask you about, but maybe I'll just offer you one. And I think that's really thinking about as AR progresses, because I get the sense that you've seen a real progression in AR since you've been working in this space, and you begin to design experiences. What does that increased sophistication mean for the work you're doing and possibly for the work that I'm doing as well? Thanks for this opportunity. It's fantastic.
Thank you for this. I'll start with the last question first, as you talk about the Victorian government. So that is the first step for any nation to take forward in order if you want to create a STEM workforce, because it needs a lot of funding. And if we talk about the schools or the universities, they won't be sufficiently alone would be doing. So a government back is always required in order if you wanted to create. So keeping the same vision, the government of India has launched the National Education Policy with the first aim to build the infrastructure. So that is why they fuel up the money into the market and they challenge the edtech companies. So there are many edtech companies that come up into the market in last 5 years, which are developing the low cost edtech products to be given to the schools and which are easy to use. Because the products which you are giving to the school kids and to the university kids, both are different. So their edtech companies, their focus was to design and develop the low-cost kits to the school students where they can learn about robotics, AI, machine learning. So with this, if I see in the 5 years in India, approximately 50% of Indian schools are now covered with STEM education, including both rural and urban areas. Now on to the second step. So once you have the infrastructure, you need trained teachers. So in order to solve that, so there is an agency that is called as AICT in India, which takes care of technical education. So they focused and they call up the higher education institutions to align with the school so that you deliver whatever the prerequisites are required for the school teachers to get trained. So now it is the responsibility of the higher education institution in to train all the nearby school teachers to use this technology. That solves the second problem, to train the teachers. Then it comes to the third, when the real time are these kids where they are going to experience. And you talked about the cognitive load. So that was my main research question while I was doing my PhD. How does this AR is really reducing this cognitive load or not? So I experimented on 140 students, and I find it out that if your instructions are clear, because in cognitive load there is one parameter that is called as mental load. So the mental load arises if the instructions are not clear. So in this case, the technology has to do nothing. If I'm teaching a student, if I'm taking a normal class structure also, if the teacher is not able to instruct properly the instruction to do an experiment to a student, that automatically raise the cognitive load of the learner. So with this technology, you need to just focus upon, are the instructions given by this application is enough for a student to understand the experiment well or not. If it is not, then it is going to definitely increase the cognitive load. So in order to avoid this or to reduce this, so initially when I was developing this, so I tested this application multiple number of times with the education experts who are working in the same domain at higher education level as well as at the school education level, so that I won't be getting feedback directly from the student. First, I will collect the feedback from the teachers. So I initially conducted a usability score for this application, whether this application is usable to be deployed at the real-time scenario or not. After that, I deployed into the real scenario, and then I can say, yes, if this application has reduced the cognitive load of the learners. And as you mentioned about you were working into the science domain, and in science domain, I know the people are working with simulations, which is now very common in engineering as well. Because if we need to design something, there are lots of simulation software available into the market, because practically you cannot see. If I need to see how an LED is glow in a fraction of a second, I cannot see with my eye. I need what is the amount of energy is consumed by an LED. I cannot see. So we need the simulations. So, but all these simulations can be embedded along with this AR to increase the effect. And in that case, my main idea was not to get diverse from different learning environments. I just wanted to give them whatever is required in the same learning environment, so that they should not be, because they wanted to read something, they go to YouTube, they find some Google sources, they read some data sheets, means they have to switch from one resource to the another resource. If we can provide all the resources are required, a minimum resource set is required in one place, I think that will be a better for a student. Otherwise, he will be juggling from one place to other place to find a resource. And that is where they lose their interest as well. Because when they are not finding the right and authentic resource, they lose their interest in understanding the concept. As today's generation, they all wanted, first you give them the resources in their hand, then they will see whether it is of their interest or not, and then they will try. So that is going to be very crucial in future as well. And the last is this is very cost effective. And when we use AR, so it is just a paper markers, and you can just print them in bulk. If you don't have a real hardware as well, that is not an issue. There is no restriction to keep it in the laboratory environment. You can give it to the student as well. They can go home, they have a mobile phone, they can scan it, they can explore it. So which increase the accessibility of a student to perform experiments from anywhere, and they can come back to you if they have some doubts. Then they can go on to the real hardware when they feel comfortable. Yes, now I know all the things. And then it will reduce the cost while damaging the real hardware. I hope I would be able to answer your questions.
Yes, thank you. It's great.
Thank you, Amit, Luke, and Peter, for a very interesting discussion. So I now would like to open to the floor for any sort of other discussion, suggestions, and comments.
Thuong, can I go?
Imali,
Yep.
please.
Thank you. So, Amit, thank you so much for this insightful talk. And it's not just about the technology, but where it started from the STEM education, how we are approaching it from AR, VR sort of perspective. I'm just keen to hear, because it's one thing to be able to teach using this sort of technology, but at Deakin specifically, because we have a cloud cohort as well, and something that we struggle with, especially with hardware-based units, is that we cannot assess the student, because the on-campus students, we see them and we can assess whether they know their things. But with the cloud student in an online environment, it is a bit hard to do that. So what is your vision about extending this system, not just for teaching, but for assessment as well?
Yes. So that is why I have shifted from the local environment or on a local host system to a web AR, so that we can develop a web application which can be deployed over a cloud, and we can have a classroom set of environment over there where a teacher has a supervision on teacher can track the progress of all the students. So once you initialize any of the task, it will be a task for all the students, just like we do on track. So you initialize through this application and you can keep track for every student performance. So either the student performed it or not, how much time a student is taken is not. So all these features, a teacher can assess the performance of the student, and onto the student side, they have a same set of experiments which they can perform with bare minimum hardware requirement. So once they are ready with the concept, they can buy the hardware and they can run into the real-time scenario. So both ways they can, teacher and a student can use this.
Okay, thank you.
Thank you, Mali.
Maybe just following up in terms of that as well. In terms for assessments, what would be your approach in terms of potentially separating some of the cognitive load of the technologies as well as other factors that might impact the way we assess our student using immersive technology?
Yes. So while assessing the in hardware-based courses, while we assess any student, the first thing we wanted to check whether he or she is able to design the circuit or not. In how much time a student is able to design a circuit, how many times he is doing the right and wrong connections, and is he is able to write the software code or not. Then we can go to the next level of assessment where we wanted to check whether the software code is working according to the circuit connection or not. So all these features, all these parameters, a teacher can assess remotely for the cloud students using this AR.
Thank you. Checking if there's any other questions from the audience.
I was going to ask, Amit, and thanks for your presentation. Really, really interesting. I was wondering the nature of your work with teachers. Do you work closely with teachers in designing these AR
Yes.
software, and what do you see as the challenges or for teachers generally? And I guess also you must have some fairly creative teachers you work with that give you a lot of ideas for extending. Could you talk a little bit about your experience of working with teachers?
I'm also an educator. So at my university, so we have a department of a design and department of a games. So whose are focusing upon creating a gamified version of any concepts. So I work along with them. I take suggestions from them how we can get more experience, immersive experience for the students. And we have we have our own school as well. So the Chitkara University have their own school up to grade 12. So we have the close association with the school teachers. We have a regular meeting with them where we came across the suggestions or the points or the pain points of the teachers. Because I go to a school, I train them, but in the real time scenario, they are doing it. So after a week or after 1 month, when I talk to them, what went well, what didn't went well, what was right or what was wrong, how they can what was their main problem while delivering this particular concept. So in I'm working in collaboration with all these three people, then I'm able to develop this system.
Thank you, Amit. We had a question from Susan in the chat. Susan, would you like to unmute or would you prefer me to read out the question?
No, that's fine. Yeah, I just wondered, well, I think that the circuit board idea is fantastic. And anecdotally, my year 10 daughter just walked past the screen. That looks awesome when you were presenting it. So she thinks it's a great idea. I'm just wondering, I don't know who could answer this, but I was interested in anti-bullying campaigns in Australia, and I researched a little bit into them, and I looked at the Theatre of the Oppressed program. A theatre program was very successful in the US several years ago now, and bullying is an ongoing issue in Australia, I guess, as ever elsewhere. But I'm wondering whether this AR has any applications for this sort of space, especially in schools that might have maybe more issues with students acting up or not getting along. I just wondered about that. I mean, I think it's fantastic for STEM, but yeah.
I think you're talking about the theatre, if I correct.
Yeah, well, it's a role play theatre where people, I think it was after.
So there are some of the companies who are working upon this area where they are merging AR with AI, where they are detecting the pose of a student, of a learner, and simultaneously there will be a 3D model which will be doing a dance or maybe playing some role. So all the motions are captured from them, and then the motions of a real person. So both are match up, and then they will give up with some rating and a score how you performed or not. So that is one way which I have seen where they have introduced AR plus AI to estimate the performance of a dancer or performance of a singer to analyze or dance on a particular item.
Right, okay, that's good. That's good to know anyway. So it probably does have applications in that area then in that case.
Okay.
Really, really good, really exciting stuff. So
Thank you.
thank you.
Susan, I might chime in there just to give a few examples I've seen of that. So we were talking about the paper targets that make AR. I've seen education work where instead of putting the paper on the table and having that tabletop experience, you put it on the student, right? Whether it's them wearing a hat or whatever, and then they get to play some kind of character. So in really, really young, so very, very young children education, the 8 and unders, there's been work where, you have the wolf and the little pigs, and you get to kind of role play what it means, what it feels like to be in both those positions. Then you also have STEM stuff where students get to play particles, and they literally are like running around pretending to be different types of particles and see what happens when they collide and that kind of stuff. So that interactivity with where that merging of the physical and digital, right? And I would say both are part of the real world, but just one's physical and one's, there's electrons and atoms. And by being able to show how that merges, there's all kinds of really neat scenarios and experiences that can be built in. So yeah, I think for the anti-bullying, that would be great insofar as, if there's 2 students on a screen, let's just say, you can actually transform what they might look like, right? And put one in a position of power versus the other, and have that reverse back, the scenario reverse out. So great.
Excellent. That's really good. Thanks. And the atom example sounds like a lot of fun. I only wish we had that at school.
I mean, my kids run around like that no matter, right?
Thank you.
Thank you for that. I just want to chime in a little bit as well. And I think immersive technologies has a really strong power of empathy, being able to sort of, experience from a different perspective. We sort of will hear concepts about avatars and virtual avatars as well. So I think for some of the applications, I think that's wonderful. They could be applied through that as well.
Awesome. Thank you.
Great discussions. Emma, you had a comment?
Yeah, thank you so much, Amit. Just the question about that you were just raising. That's also an issue in medical education. I'm from a medical background, and the use of like mock patients, actors coming in, and particularly around issues like Aboriginal health, where it can be like a huge cultural load on people to provide those mock clinical encounters. So that's another, I mean, not unproblematic, but another point. But the question I wanted to ask was just something you said quite early on that caught my ear. If I remember correctly, you were saying that in computer programming now there's like more women than men. So there's this like reversal of the gender bias that's been in a lot of STEM education, which is really interesting because, you know, computing, of course, famously started off as a female profession of women that would actually make computations. So I'm just thinking, wow, that's interesting if that in India, that's like returning to its the gendered roots of the profession. But it raised the question for me about whether there's particular kinds of learners that benefit more or less from AR in education.
Look, it depends upon the domain in which you are working. So as I say, because I said it because I'm teaching from last 15 years and I have seen the rise in my class as comparison to the male and female ratio, if I say. And when it comes to real-time working onto the hardware side, you will see the interest of females are less as comparison to the boys. And with this technology, this gender gap has been reduced because it gives you the feeling that of comfortableness that you are comfortable with the hardware and you can play around. So that has increased.
Yeah, so that's interesting. So do you think it's like the gendered norms of the way women are brought up, like not to be, you know, playing outside and building things and destroying things? Is that what it is? Or is it like, you know, more awareness of the value of these tools? So, you know, they're more concerned about damaging them, or where do you think that gender
It is more
difference
about
comes?
damaging. It is more about damaging things.
Right. Thank you.
Thank you.
Thank you, Emma. Thank you, Amit. So while we're waiting for other questions, from your experience, could you comment on what you see as the adoptions or acceptance rate of AR technology specifically, and emerging technologies in general among the education and training sectors?
Yes. So, Thong, as we see, when the AR was evolved, so it has started with an entertainment, and there are a lot many applications has been developed to the entertainment. And when we see the rate, this AR companies or AR edtech has evolved, it has immense. So, which automatically shows if you look back after before 10 years, so there are, I think, one or two companies. And now this Unity, the tools, the companies which are using these tools through which we are developing this AR application, they have also arisen, and the education domain area they have also penetration. So just like if we see for the medical sciences, then we see the architecture side, engineering side, then at the STEM education. So all the areas of the education has a steep rise with the advent of AR, and it is clearly shown in the research. The future would be where we would be seeing and digital into the real environment in the real classroom. That is where we are leading. And with the help of the industries, some of the industries, they have made some applications in India, which we are using for engineering, for maintenance as well. So you can you can use a complete application for the maintenance of a factory. So a remote trainer, they can guide the subordinates how to repair this particular machines. So that is already being deployed in India. There are companies just like a PTC who's working in this area, and they have a complete solution for this. So we are waiting for the prominent players in the market for when they come up for the education. Although there are some of the companies which has just like XR is their company which has launched some of the products as a hobby. But the lack is they are not aligned to the curriculum. So once they are aligned to the curriculum, its acceptance would be definitely there in the market or in the school education level.
Thank you. So Based on your experiences on applying sort of AR technologies to this sector, what would be your advices for other educators, researchers, practitioners working with emerging technologies or devoted to improving education sector?
Whenever we wanted to design some application, first we need to look for its alignment to the pedagogy. So the tool should be first aligned to the pedagogy and then to the curriculum. Otherwise, if we are developing something which is not aligned to the pedagogy and the curriculum, it won't be have a good lifespan. So it will be just for hobby. So my advice only to take care for the curriculum and the pedagogy to be followed so that it should become for the real cause. It should become only for the short-term life. It should become for the real time where its usability and scalability is large.
Thank you. Thanks, Amit. Just talk about your experience of visiting and collaborating with us. So I just might invite you to comment on your reflections on the collaborations that we have so far, and I'll also invite others from Chitkara and Deakin to comment and sort of share your experience in this collaboration as well.
Yeah, so I'm collaborating through Chitkara with Deakin since the 2020. So the collaboration started during the COVID era with the software engineering program, which come up, and I have been invited to teach this software engineering program, the DCT courses there, that is data capture technologies. So that was the first interaction which I had with the Deakin faculty. I came to know about how the Deakin style of teaching is there, what the tools they are using, how they are assessing, and specifically about the continuous assessment methodology. Because here the assessment methodology at Chitkara is different. So we are more towards a pen and paper based assessment. So now we shifted from a pen and paper based assessment to a continuous and online tool based assessment, which was a challenging for us. But with this support and this collaboration, now we are in a position which we are very comfortable to use this. And now we, in terms with the Deakin faculty, we are moving ahead to have some research projects. So this a fellowship is a one answer to that, which we have, and then there are a couple of research publications with the Deakin staff we have, and then there are coming projects with the Deakin staff. So that is what the collaboration has progressed, and it has strengthened between the ties between the two organization and the countries.
Thank you. I just want to invite Imali, who's working with Amit who's over here, to share some of her experience working with Amit.
Thank you, Thuong. Yeah, so I think this project, sort of the idea came through Thuong because both of us are teaching embedded systems unit, and then the challenges that we face when we are teaching students about these embedded systems, especially for software engineering students, because they are so much used to programming, coding. So for us to convince them that hardware is equally interesting and important is a bit of a challenge. So that's where, because Amit has worked on this extensively before as part of his PhD, and this was his specialized area. So that's where this idea came in, or maybe we can extend this into web-based. So we have worked across this. So it was a very good experience to actually work on this sort of a thing, going beyond hardware and then bringing the hardware experience much closer to the students and also for us staff as well. So I'm really thankful that Amit was happy to share his baby project with us and then use it in a constructive manner. And we had some capstone students working on this project as well, so not just the SSN project. So it was quite useful for the students and us in many ways. So thank you so much, Amit, for making that happen and letting us into that project of yours. Thank you.
Thank you. Thank you. I just like to add one more thing. So the purpose, what I feel is the purpose of the research is if we bring it into the real environment, because most of the time we do a research and it left only in the papers. And certain there are certain restrictions through which we cannot bring it into the real users. So I feel if we are working onto the, or if we are researching, so that research outcome should be directly impacted to the society. That is how I thought of to pick up an area and develop something which can be directly benefiting the society. Thank you, Mali, for the support throughout this.
No problem.
Thank you. That's a wonderful note for us to end today's discussions on societal impact is what we're striving for in educated researchers and practitioner. Please everyone join me again in thanking Amit for a wonderful presentation, the very useful discussions. Thank you, Peter, Luke, and Emily for contributing to our discussions throughout today as the discussions. So before we go, I just want to share some upcoming sessions from SSN. Coming up in about a few weeks' time, we do have the SSN seminar with Professor Catherine Bennett, Introversion, Discipline, Government Structures, Providence and Policy. So for those who's interested, please scan the code or contact us for more information. And also upcoming further down the track, we have doing interdisciplinary 6 years of Deakin Science and Society Network. That's going to be happening in July in our city campus, and the code here for us to scan in as well. We do encourage people to register for those because we have a stellar panel of speakers. Some is here with us today, Emma. So he's looking forward to very great discussions in a very sort of busy year ahead for us as SSN. So with that, I would like to bring the session to a close. Again, thank you everyone for contributing to such a very useful discussions, and it's great to see wonderful impact from our research. Thank you.
Thank you.
Thank you, Thuong. Thank you, everyone.
Thanks.
Thanks, everyone. Great to see you.
Thank you, everyone.
Thank you.